All right, here we go. Solving equations. Okay, so we've learned about equivalent expressions. So remember expressions, we had variables and they were not equal to anything. Now we are dealing with equations, so they're equal to something. So now we are going to find what value that variable stands for. So now we're going to go for treasure hunt, finding the unknown now. All right, solving equations. Model and solve one step, one variable equations and inequalities that represent problems including geometric concepts. All right, with adding and subtracting, the goal, and this is also with multiplying and dividing, the goal is to isolate the variable. So isolate means to get it by itself. You're going to isolate the variable. That is your main goal. But how? How do we isolate the variable? We use inverse operations. So remember the inverse property of addition? So we're going to use the inverse property. So the inverse property, think of the opposite operation that's going on. So first, so right here, here's your example. We have J minus 12 equals 68. So first you want to identify the operation and its opposite. So ask yourself, what operation is happening here? Well, we're subtracting. What is the opposite of subtraction? Well, it's addition. So we're going to show the work to undo it. So how do we undo subtraction? With addition. And we must keep both sides balanced. That means if I'm going to add on one side, I'm going to add on the other. Or if I'm going to subtract on one side, I'm going to subtract on the other. So we're going to show work to undo it, keep both sides balanced, and last, we're going to check our solution with substitution. And what I mean by that is, we're going to check our solution with substitution. We're going to take our solution and substitute it in the variable to make sure that it checks out. Okay, so here we go. We're going to solve for J. So first, identify the operation and its opposite. So we identify that subtraction is going on, and its opposite is addition. So if we're following the property of inverse, so we have 12. So we're going to add 12 to undo it. We're going to keep both sides balanced. So what I do to one side of the equal sign, I have to do to the other side of the equal sign. So I'm going to have to add 12. Now this ends up canceling my 12s to isolate the variable. I bring down my equal sign. I have 68 plus 12. That gives me 80. So let's go substitute 80 in for J to make sure that works. So then I have 80 minus 12. Yes, that gives me 68. So J equals 80 is correct, and I can plot that on my number line. So if J equals 80, right there, we're going to color it in because it equals it. So it should be a closed dot on the number line right at 80. All right, now we're going to solve for C and M. All right. So again, we're going to identify the operation and its opposite. So what is going on here? What operation is going on here? C plus 4 equals 16. So we're going addition. So we're going to subtract. So we're going to do our inverse property. So I'm adding 4. So I'm going to take its opposite. So that's going to be minus 4. I'm going to keep it balanced. So what I do to one side, I do to the other. Okay, since these cancel out and give me 0, that brings my variable down, which isolates it. I bring my equal sign down. Now I have 16 minus 4. That gives me 12. So I'm going to go substitute and check my solution. So I get 12 plus 4 equals 16. So C equals 12 is correct. That is my answer. Now I'm going to solve for M. All right, I'm going to identify what operation is going on here. So it's subtraction. So the inverse of subtraction is addition. So I'm going to undo it, keep both sides balanced. So I'm going to add 8 and add 8. These cancel out, which brings down my variable, which gives me 10. Okay, so right here we need to make sure, I'm going to rewrite this and show you. We need to make sure that we do not go to this side and try to cancel out our 2, because then we are going to end up canceling these out and we end up with m plus 10, and that doesn't solve for our variable. That doesn't give us our goal of finding out what is m standing for to be able to plug it in to find our solution, that when I'm subtracting some number by 8, I'm getting 2. So make sure that you are doing the operational side, not the side that it's equal to. Okay? All right. Moving on to the back. So now we're going to do multiplication and division, and we are going to practice these for 2 days. Okay, here we go. So still we do the same thing. So remember, when we are working with multiplication and solving equations, we are going to see this a lot. When a number is smooshed up to the variable, okay? When you see a number smooshed up to the variable, it is being multiplied. Okay, remember that? Also, right here, remember this. If a number is smooshed up to parentheses without a symbol in between there, that is also being multiplied. So 4 times y, that would equal 4y. That means I'm multiplying 4 to some number y. Okay? And also remember, now you're in 6th grade, this means c divided by 4. Okay, we're going to see fractions a lot as division, especially with equations. Okay, here we go. So we're going to identify the operation of what's going on. So that number is smooshed up to the variable, so that means we are multiplying. So we're going to have to do division to undo the multiplication. So I'm going to divide each side by 5. So divide by 5. Divide by 5. Well, 5 divided by 5 is 1. So I'm just going to bring down my variable, which is d. And my equal sign, well, 35 divided by 5 is 7. I get d equals 7. So if I plot it on the number line, I'm just going to close it. There we go. Easy peasy lemon squeezy. All right. Division. Now division, to undo division, I have to multiply. So I have to multiply by its reciprocal. So right here, if I'm doing division, I'm going to have to multiply by its reciprocal. So the reciprocal of 1r over 3, that's called, we can just multiply that by 3 over 1. But what I do to one side, I have to do to the other. So this, I have to multiply this side by 3 over 1 as well. Okay, and when I multiply my fractions, remember I multiply straight across. And I get 3r divided by 3. These cancel out because 3 divided by 3 is 1. I'm left with r equals. And then I get 27 times 3, which is 81. And 81. And then 1 times 1 is 1. So 81 divided by 1 is 81. So I get 81. So let's go plug that in for r. So 81 divided by 3 equals 27. So yes, that checks out. and that is my solution. Just like right here, if I go plug in 7 for D, I have 5 times 7, which equals 35. So yes, that checks out. So D equals 7 is my solution. All right, make sure you are using your notes. I've shown you every step of how to use it, okay? So here we go. We're going to have 2 days to practice this and use your notes. Have a good day.